In this video, I'm going to talk about implicit differentiation. So before you watch this video, hopefully you've probably already learned about regular differentiation and the various rules relating to it, such as the chain rule, the product rule, and the quotient rule. So you should know that if you're asked to find dy dx of a function, let's just do an easy one, y equals x squared, then you should know to take the derivative of both sides and divide. So then you know that dy dx, or the slope of the tangent line of this function, is going to have its own function of 2x. So if you want to find the slope of y equals x squared at the point x equals 1, you're going to plug 1 into here and you'll have the slope of 2. So that's easy. So now I'm going to teach you how to do implicit differentiation, which is just the same thing as regular differentiation, but it's just a way to do harder functions where you can't put y equals something in terms of x. It's when you have the y's and the x's all mixed together and you can't figure out how to put y equals. So let's do an example. You can, and also in implicit differentiation, you use the chain rule, the quotient rule, and the product rule all in the same ways as in regular differentiation. So example 1, find dy dx for the function y squared minus 6x squared equals 3x plus 5y minus 12. So in implicit differentiation, you're differentiating the whole function at one time, and you're always going to differentiate with respect to one of the variables. So since this problem asks you for dy dx, that means we're differentiating the whole function in terms of x. So if you have a y, if you're differentiating a y, you're always going to have to write dy dx after it as part of the chain rule. But if you're differentiating, so if you had y and you were doing implicit, then you would write dy dx. So if you had an x and you were doing implicit, then you in theory would write dx dx, but that's just 1, so you don't really have to write anything if you have an x. So let's start off. First we do y squared. So we're going to do the same thing that we did earlier, just 2y, but this time we have to do the chain rule on the y, and so now we have dy dx. And then we just continue on as normal, minus, so we're going to differentiate this 12x, and it would just be dx dx, but that's 1, so we just don't write anything and we move on. So 3, same thing, we just move on because it's an x. And then 5, and then since this is a y, we have to write dy dx, and the minus 12 disappears. So now what we want to do is we want to get everything that has a dy dx in it on one side of the equal sign and everything else on the other side. So we're going to move the 5 dy dx over here, and equals, we're going to move the 12x to the other side, and then we're going to factor out the dy dx. And then final step, we're going to divide, so we get dy dx equals 3 plus 12x divided by 2y plus 5. So that's your final answer. Okay, so let's do another example. We're gonna use this same problem, but we're gonna find the actual slope at a specific point. So I'm gonna example 2, but I'm gonna write this equation at the top so we remember what we did. dy dx equals 3 plus 12x divided by 2y plus 5. Okay, so we're asked to evaluate dy dx when x equals 1. So we're going to use the original equation to find what y is when x is 1. So our original equation is just the same as the last problem, but x equals 1, so that we're going to have y squared minus 6 equals 3 plus 5y minus 12. And this is just algebra 1 stuff. Equals, actually I'm gonna move that over there. 3 equals 0. So now we're gonna do the quadratic equation. Y equals b negative b plus or minus the square root of b squared plus or minus 4ac all over 2a. So that should equal 5 plus or minus root 13 over 2. So I'm just going to write that up here. We're going to have two different y values that we're going to have to plug in. So evaluate here, we're going to have dy dx equals 3 plus 12 over 2 times this crazy thing. We're going to do the positive one first. Plus 5. So that equals 15 over, the 2's cancel out, so 10 plus rad 13. Okay. So that's one of our answers, and then now we have to do minus, so 15. I'm just going to use my other step. Minus. It's a 5. So those cancel out, and we have 10 minus rad 13 on the bottom. So we have two answers for our dy dx. It can be two different things depending on depending on which y value we're at. Okay, so now example 3. So now we're asked to find dy dx for sine of 2x plus 3y equals 2y plus 7. Okay, So this is going to involve the chain rule and the product, no, just the chain rule. So we're going to have dy dx equals cosine of 2x plus 3y. And then the chain rule means we have to do the implicit differential of this outside times this. So we're going to have 2 plus 3 dy dx. And then the other side, just 2 dy dx, and the 7 disappears. So now we're going to have to do the distributive property for this entire thing for those two. So we're going to have 2 cosine of 2x plus 3y plus 3 dy dx of times cosine of 2x plus 3y equals 2 dy dx. So we're gonna again get the dy dx's on the same side and everything else on the other side. So 3 dy dx cosine 2x plus 3y minus 2 dy dx equals negative 2 cosine of 2x plus 3y. So now we're going to factor out the dy dx. And leave that side. Okay. So now we're going to divide, and then we're going to get dy dx by itself, and that should be our answer. Okay, so that should be your answer. So now moving on to example 4. So this time we're going to do a double implicit differentiation, and it works just similar to the if you were asked to find like y double prime of x, but this time we're going to use implicit differentiation both times, and the way you write that is d squared y over dx squared, which you may have learned when you learned regular differentiation. So we're going to find that for x squared minus y squared equals 8. So we're just going to, at first we're just going to find dy dx using implicit differentiation. So 2x minus 2y dy dx equals 0. So then we're going to move the dy dx to the other side and then divide. So we're going to have x over y equals dy dx. So that's just our first step. We're not done yet. So I'm going to write that over here to the side. Dy dx equals x over y. And then we're going to do the next round. So we're going to use this right here, and we're going to do d squared y over dx squared, we're just going to do implicit differentiation on x over y to make it double implicit differentiation. So we're going to use the quotient rule, so low times d high, which is just 1, minus high d low, which is dy dx in implicit, and then divided by low squared. So now we're gonna have basically what you do is you just plug in the x over y in for the dy dx, and then you'll have everything in terms of just x and y. So we're gonna have y minus x squared over y squared. So you can either simplify that if you want to, and then you'll have just 1 over y minus x squared over y cubed. Okay, so that's your final answer. And now, moving on to example 5. So now we're being asked to find dy dx for the square root of x times y equals x minus 2y. So to make this easier, let's just rewrite this as xy to the 1/2 equals x minus 2y. So then implicit differentiation, we're going to use the chain rule and then the quotient rule. So 1/2 of xy to the negative 1/2. And then we're going to do the chain rule of the derivative, because we need to do the derivative of x times y out here. But to do that, we need to know the quotient rule. So we're going to do this in implicit. So we're going to have the first times the derivative of the second, dy dx, plus the derivative of the first, so that's just 1, times y, times the second, which is y. So then we have equals 1 minus 2 dy dx. And then we're going to have to do the distributive property on all this, and then get dy dx on the same side. So then okay, so I'm running out of room, so I'm just gonna erase this work up here. Hopefully you have it copied down. So I'm gonna factor out dy dx. And then we can make these two terms here have a common denominator, which will then cancel out once we divide this by this. So we're gonna have x over 2 rad xy plus, we're gonna have 4 rad xy over 2 rad xy. And then same thing over here. I can erase this stuff now. Negative y plus over 2 xy plus 2 rad xy over 2 rad xy. And then combine these. So we have we can just divide divide this by this, then the denominators are going to cancel out, and we're just going to have over x plus 4. So that's your final answer. And now for example 6. The last example. So this time we have to find the slope of the tangent line, which is just another way of saying dy dx, for x cubed plus y cubed minus 6x y equals 0 at the point 4/3, 8/3. And we're just assuming that that point falls within the function here. You can plug it in to check if you want to, but you don't have to. So, slope of tangent line of this function at that point. So that's just a fancy way of saying what we've been doing all along. 3x squared and then plus 3y squared dy dx minus 6. We're going to do the product rule here. The first times the derivative of the second plus, but I'm just going to go ahead and distribute that negative, so, and the 6. So plus the derivative of the first times the second equals 0. So we're gonna move everything to the same side like we've been doing. And factor out the dy dx. And then divide. So now that we have this is our dy dx, so that's our slope equation, but this problem asks us to plug in a point for that. So what we're going to have to do is plug in, I'm going to erase this work up here, and then use that space to plug in our point. So dy dx equals 6 times 8/3 minus 3 times 4/3 squared over 3 3/3 4/3. Okay, so we're gonna have 16 minus 16/3 divided by 64/3 minus 8. So that should equal 0.8. I did it in my calculator earlier, you can double check. So our slope of the tangent line of this function up here should, at this point, should be 0.8. So I hope you learned a lot about implicit differentiation, and I hope this helps you. Thank you.